So we are going to start this second day. Welcome everyone for this afternoon. It will be dedicated to in the first time red teaming on the internet, two offensive security talks, and then we are going to give the stage to our blue team. And at the end of the afternoon, it will be concert time. We are going to speak about it later. And now, please welcome Mathieu about who is going to speak about Symfony pen testing. Mathieu, the stage is yours.
Thank you. Can you see my screen? Can you hear me?
Yeah, everything is fine.
Okay. So hi everyone, my name is Mathieu, and today I'm going to introduce you a tool we developed at Synactive to load information from misconfigured Symfony applications. So just a few words before beginning. Synactive is an IT security company based in Paris, but we also have teams in Toulouse, Lyon, and Rennes, as well as other remote colleagues throughout the country. We focus on offensive security, and our activities can be divided between pen test, reverse engineering, and development projects. So a bit of context about this presentation. Symfony is an open source PHP framework used for building web applications. And during assessments, we came across some Symfony instances deployed with debug features enabled in a production environment. So these features are actually part of a Symfony component called the Web Profiler. And from there were two things we wanted to do. The first was to loot as much information as we could, and the second was to automate everything because doing it manually would have been painful. So before going further, I'd like to emphasize the fact that we are not dealing with Symfony vulnerability. We are only taking advantage of a Symfony component, the Web Profiler. And in fact, the Symfony documentation clearly states at the very beginning that this component should never be enabled in a production environment because it will lead to major security vulnerabilities. So the core component of Symfony is its kernel. And according to the Symfony version your application is using, the kernel will be instantiated differently. In older Symfony versions, there were two files for two kernels. The first one in app.php was the default kernel created with production parameters. And the second one in app_dev.php was development kernel with debug features enabled. So in this case, according to the URL you use to reach your application, your request will either go through the first or the second kernel, and in the second case, you will be able to use the sensitive features. However, in the latest Symfony versions, they merged those two files, and now there is only one kernel instantiated for each Symfony application, which is in the public/index.php file. So in this case, as there is only one kernel, your application can either be deployed in production or development mode. So from this, I can see two scenarios for us attackers. In the first case, there is only one Symfony instance, and all the information you will be able to get from the debug features would be valid on the same Symfony instance. So this is the best case. However, in the second case, you will have to have access to both a production and a development server because they are separated, not all the information you will be able to loot from the development features will not necessarily be valid on the production server. So this will focus what kind of information we want to loot from the debug features. So this is actually the first thing you see when you come across a Symfony application that has been misconfigured. This is the profiler toolbar. So this is not much, but there is already some information, the Symfony exact version, the PHP version, and some of the parameters of the deployment. And then if you go through the links, there is, for example, the PHP info. And as Symfony usually relies on environment variables to pass parameters to the kernel when the application is starting. In this section of the PHP info, you will be able to find very valuable information such as secrets to external applications, API tokens, and so on. And there is also the application secret, which Symfony uses internally to perform some actions that we will see later. Then if you move to the profiler, the actual profiler panel, there are multiple tabs on the left, and one of them is the routing panel. This panel will enumerate all the routes of the application. In fact, when you request a resource from on the website, the profiler will go through the list of the registered routes for the application until one matches the resource you are requesting. But if you trigger a 404 error, then the profiler will simply list everything. So this is valuable information when you want to attack the application. Then the second panel is even more interesting because this panel will list all the requests that have been issued to the application. And for us attackers, we are especially interested in requests containing data, especially post requests, and even more especially the login requests, because we will be able to extract the information that have been passed to the application. And here we can see Symfony tries to hide the sensitive fields of the form, such as password, but actually, if you scroll down, there is a section where the Symfony profiler will just display the raw request content. So you can grab the password from there. Another feature regarding authentication on your application is the Remember Me cookies. This feature is actually not enabled by default on Symfony applications, but it is popular enough to be considered. So Symfony provides built-in interfaces to create such cookies, Remember Me cookies, and one of them, which is the default one, uses the function here, generate cookie hash. This function relies on multiple parameters, and these parameters are the username, the user password hash, and some other elements around the user. So they take all these parameters, put them together, then perform an HMAC using a secret key, and the resulting value is passed to the cookie so that the user can authenticate to the application again. So the secret key that is used to craft the cookies is actually the application secret that we just saw earlier in the PHP info. So with this value and with the value we can find in the profiler panel in the session section that we can see here, we have all the elements we need to craft cookies ourselves. And we just have to base 64 everything. We can add an unlimited lifetime for this cookie because we also control the timestamp until when the cookie is working. And we will be able to log to the application as another user. So we just saw that we can already get the credentials that have been issued to the application, but there may be some cases where you cannot use them directly For instance, if the application is implementing multiple factor authentication, then this technique could be used to bypass such protections. And the last feature that Symfony provides, the web profiler provides, is a file viewer. When you are working on the application, when you are developing it, this feature is pretty handy because if, for instance, errors are raised in the source code, the profiler will show you the file where the error was raised, and it will even show you the exact line. So this allows you to view the file contents. And for us attackers, we will not restrict ourselves to the files that the web profiler wants to show us. In fact, we can choose whatever file is in the root directory of the application. And this is the case for the config files, for example. So here, the config/services.yaml file is the default, one of the default configuration files for Symfony. And this file is interesting because some of the parameters that are passed to the kernel are in this file, as well as some secrets for external services. So once again, this information is useful, but as I told you earlier, there may be cases where all this information, all the secrets you got from the web profiler are not valid on the production server. So in this case, the information we want is the actual source code of the application, because if you manage to get the source code, then you will start to look for vulnerabilities, and then you could attack the production server. So the only problem is the web profiler has no directory listing feature. You have to file path to the file you want, and you cannot guess reliably the files that you want to download, the source code files. So the way to get around this is to look in the cache files. For each Symfony application, the Symfony embeds a caching system, and all the files that are cached for your applications, are under the var cache and a folder name depending on the deployment environment, which will likely be dev, because your application is in development mode. So the files under this directory you will be able to view them through the features because they are under the same root directory. And the file we are really interested in is the kernel cache file, because in this file you will find all the parameters that have been passed to the kernel, and also the services, the PHP classes that have been registered for your application. And with the PHP namespaces that you will find in this file, you will be able to guess the file path and extract the source code. So luckily for us, the file name for this cache file is not random, because that would have been a problem. But instead, it is composed of constant parts and parts that depend on the deployment. So for instance, src will be the root directory for the source code of the application. Dev is the deployment mode. Debug is whether your application is in debug mode or not. App kernel is the PHP namespace to the Symfony kernel. And the green part is a fixed part. So then you just have to request this file using the web profiler feature. And as you can see in the highlighted line, you will find the PHP namespaces to the PHP classes of the application. And as Symfony uses default namespaces, which are app, for instance, or app bundle, you will be able to convert those namespaces to actual file system path, and then to download the source code files that you're interested in. So in the end, This is actually all what the tool EOS is doing. You start the tool, you scan your target, it will go through the request logs, it will extract all the credentials it finds, it will extract also the user roles, it will go to the PHP info, extract all the secrets from there, it will try to download the project files, the configuration files, and the source code files. So in this example, for instance, on the right, you can see all the part of the files that have been downloaded by EOS, by the tool. So then from there, you can start looking for vulnerabilities in the source code and attacking the actual production server. So the tool has been released on our GitHub a few weeks ago. Feel free to use it. And if you just want to test it, see how it works, Symfony actually provides a demo application containing real-world components, such as the user managing mechanism, you can edit content, and so on. So this is a perfect target for the tool. And this is what I actually used for this presentation and when I was working on the tool. So to conclude, these are very basic tasks, nothing very complicated, but the tool now does it automatically. You don't have to worry about anything. It does it within a few seconds. And once again, this reminds us not to expose debug features in production environments, because this will lead to major security vulnerabilities in your infrastructure. So this is it for me, and thank you for your attention, and I'm ready to answer questions if you have some.
Thank you very much.
Thank you.
No question for the moment in the Q&A, but I have got one. Symfony is really used in the PHP world. And have you got some idea to extend your tool further than to check the debug environment in production? In other words, would you like to extend to check the vulnerabilities, the potential vulnerabilities of the different application deployed on that kind of environment? And have you got some ideas to extend your tool, or it is only focused on the debug portion?
Yeah, good question. At the moment, the tool is only focusing on debug features, but there may be components that can be reused in a production environment. I'm thinking about, for instance, if you have an SQL injection and you are able to extract the user hashes, and you may be able to use these hashes to craft Remember Me cookies, as I just explained. But apart from this, I cannot see direct application for this tool if it's not in development mode.
Yeah. Okay, thank you. People outside, have you got some question to Mathieu? So we are going to be able to say thank you very much, Mathieu, and we are going to stay on pause for 5 minutes to stay on track with the schedule. Thank you very much, Mathieu.
Thank you, everyone. Bye.
Bye-bye. So we are back to launch our second offensive talk. We are going to give the stage to Jonathan to speak about IoT network mapping. So, Jonathan, the stage is yours.
Yeah, thank you for the introductions. So let's share my screen. So everyone can see my slides?
Yes,
okay.
It's
okay. So today I'm going to talk about IoT Map, a system capable of modeling heterogeneous IoT networks. Before that, I will present myself. So I'm Jonathan Tournier. I'm a PhD student in a CIF agreement with the city INSA Lyon and AlgoSecure. I'm also a red teamer, pen tester, and security consultant at AlgoSecure. So let's go back to the main subject. So what are heterogeneous IoT networks? To understand what it is, I took the example of the IoT deployments for a small company or personal usage. And the first thing to do is to choose the IoT technology you want to deploy. In my case, I choose the ZigBee protocols. So I boost some devices compatible with the ZigBee protocols and deploy it in my network. I connect the hub of the ZigBee network to the private networks to use the smartphone applications or the web applications to manage or handle the IoT networks. Sometimes later, maybe months, maybe years, you want to extend the IoT networks, and a new protocol is released with better performance and more suitable for your needs or your requirements. In this case, it's the 6LoWPAN protocols. So I choose these protocols and I want to deploy it in my networks. So just as for the ZigBee networks, I buff some devices compatible with the 6LoWPAN protocols and deploy it in my network. I connect the hub of the 6LoWPAN networks to my private networks, and I can use the smartphone applications or the web applications to manage and handle the 6LoWPAN networks. But the thing I really want to do is to be able to connect some devices from the ZigBee networks to some devices to the 6LoWPAN networks. Or in this current state, none of the devices are able to communicate with the other protocols, but two devices are multi-protocols enabled, and two routers. One use the ZigBee protocols and the BLE protocols, and the other use the 6LoWPAN protocols and the BLE protocols. So I deployed a BLE communications between the two routers, and I developed some applications to ensure that objects from the ZigBee networks can communicate to objects from the 6LoWPAN protocols, from the 6LoWPAN networks. And to increase the functionalities or in my networks, I deploy two other objects with BLE communications. So it's the final state of my networks. And in these networks, there are three different protocols with different smartphone applications or web applications to manage independently each network. So it caused some security issues regarding some devices using different protocols and uncrafted applications. So what about the IoT security? The IoT security is, just as this slide, very confused. We can find every kind of security threats, from the information leak with a teddy bear, for example, to the most critical threats, such as the human life attack, where an attacker may remotely take the control of a pacemaker and activate or deactivate it. So how can we improve the IoT security? From my experiences as a pen tester, I think that the penetration testing solution is a good thing to evaluate or improve the security of networks. And penetration testing follows some methodology divided in different steps. And in these presentations, we will focus on the first step, the information gathering step, or more precisely, how to model networks. Of course, it exists very multiple tools to playing with IoT protocols. I see some Killer Bee, ZigBee, Z-Monitor for ZigBee protocols. We have Betelgeuse or Betelgeuse for BLE communication, and so on and so on. However, in this list of tools, each tools is specific to unique protocols and cannot be used to analyze or play with another protocols. So what about heterogeneous IoT networks in which there are multiple protocols deployed? In this presentation, I present IoT Map. That is a tools that merge different existing tools to be able to intercept, to play, and analyze different IoT protocols simultaneously. To do that, we provide an architecture divided in 3 parts, with the sniffing parts that collect and instantiate different existing tools. For instance, we can use RZ USB stick with the Killer Bee firmware embedded to intercept ZigBee communications. We can use a CC2531 device with the SenseSniff firmware to intercept 6LoWPAN communications, or we can use the Betelgeuse firmware in the microbyte devices to intercept BLE communications. Each device produce a pcap of the intercepted communications, and we merge all those pcaps using a unified format we defined, and use this file to produce the modeling. So the file is take as input by the modeling modules that generate a modeling, as we can see on the right side of the slide. And a database and visualization module is provided to allow the user of IoT Map to see the representation of the network. Let's get deeper in the modeling modules. As I said, the modeling modules produce a modeling based on a graph, and we decline the modeling into 4 different graphs, where each graph brings a new knowledge, a new level of information that can be used to the next graph to be built. We use an iterative approach and start from the data link graph. The data link graph highlights some point-to-point communications. So as you can see in the picture, right to the text, we have 4 different devices where each communication between 2 devices is represented by a draw with the arrow representing the orientation of the communication. And the unified file format is used to produce this data link graph. When this graph is produced, the information brought by this graph is used to build the network graph. So the network graph highlights end-to-end communications. What I mean by end-to-end communications is the real destination of the message. When a device wants to send an information to a device, if this device is not in the radio range, the message pass through different hubs to reach the destination. In the network graph, we represent directly the final destinations. So as you can see, the lights on top of the picture in reality communicate with the router in bottom right of the picture. And to make this graph, we use network relative information stored in the data link graph. Now, with the information brought by the network graph, we produce the transport graph. Transport graph expose the role of each device and expose the data flow. So as we can see here, we have a bidirectional communication between the light and the router. And in the transport graph, we replace these bidirectional communications to an oriented one-way communications from the light to the controller. And we tag the light with the source role and the controller and the router with the controller role. We have 3 different roles: source, sink, and controller. And to determine the role of a device, we define some patterns we use to the network graph, in the network graph, to produce the result, as we can see here. Finally, we have the application graph, the last graph of the modeling. And this application graph represents an application that IoTMap is able to detect. We define different patterns where one patterns represent one application that IoTMap is able to detect. And on the picture on the right of the text, we can see that finally the lights interact according to our patterns to the outlet in this case. So before to do a small demonstration, I will present the setup I use to make the demonstrations. So we deploy a physical testbed with 3 different protocols: the ZigBee protocols, the BLE protocols, and the 6LoWPAN protocols. We deploy 12 different devices with the different specificities. Sorry. And we develop several applications such as monitoring applications or actuator sensor applications. To the demo, I intercept 1 hour of traffic to make the demonstration more realistic. So let's go to the demonstrations. Everyone can see the 2 parts of the screen?
Yes, that's fine.
Yes. Okay. Thank you. So on the bottom of the screen, we are the framework IoTMap. I already launched and import different PCAPs from IoT networks because regarding the size of the PCAPs, it may take some time to import the PCAPs in the database. And on the top of the screen, we have the Neo4j web applications allowing us to see the representation, the modeling. So when we import the PCAPs, the first thing, the IoTMaps automatically generate the first graph, the data link graph. And as we can see here, the relationship types sections highlight the different graphs that are stored in the database. So if we click on the layer 2, we observe some we observe the graph representing the data link graph IoTMap is able to produce according to the different interception from different IoT networks. So from this graph, we're gonna create the network graph. So it may take some time to Neo4j to refresh the page. So the network graph appear here, but if it takes some time, you can just refresh the page to accelerate the actualization. So if we click on the layer 3, the layer 3 is just a simple version of the network graph representing here. And compared to the layer 2, we have some more edges between devices representing the network communications. So from this graph, let's create the transport graph. Let's get refresh the Neo4j database. And here we have the transport graph. As you can see, each node on the layer 3 graph has been tagged with the role of the devices in the networks, and each bidirectional communications are replaced by one-way communications from the source to the sink or the controller. So here we have some representation of device and the role of each device in the networks. And finally, we just build the application graph. Let's refresh the web app to get the graph. Here we have the interact pattern that IoTMap is able to detect, and we can see that some nodes are involved in the applications. The thing that is important to say is that this node with the name ID2 is involved in 3 different interactions with the node with the name ID1, with the name ID5, and the device with the name ID4. If we go back to the trans edge and take the node with the name ID here, with the name ID2, that is involved in 3 different interactions, and with the name ID5, we can see that normally those 2 devices are not able to communicate directly. And this device is usually using BLE communications to communicate, and this device use ZigBee communications. So the pattern we define to detect interaction between devices in the networks is able to abstract the protocol used to communicate in order to detect if some devices interact with other devices. So let's go back to the demonstration, the presentation, sorry. So to conclude, we have different statements. Currently, IoT security is mostly focused on monoprotocol. As we can see, there are some tools providing some security features to a unique protocol. And heterogeneous networks will be more and more present, making legacy networks that are rarely updated, remaining the weak places of the networks. And what we consider is to study the IoT security from a global vision and not from a single point of view from the protocol or the device, for example. As FutureWorks, we are a lot of FutureWorks, such as the improve IoT map for different tasks, such as the information gathering, by adding an encrypted traffic analysis, add more patterns to detect more applications, and add more protocols to be able to analyze more networks. So thank you for your attention. If you are some questions, feel free to ask them.
Thank you very much for this presentation, Jonathan.
Thank you.
I think you have already 2 questions. If you can read them and then answer them. You have got it. You have got them on Q&A section.
So the first question: how the different interfaces on different technos of one single device can be mapped as belonging on the same node? Typically, they have different mics. So yeah, it's not done automatically. We need a human interaction to make the mapping between devices, between a device using different interfaces. The second question: are there automated or standard ways to see some part of the traffic being encapsulated or traffic being encapsulated on another physical layer? ZigBee traffic embedded in some intermediate Wi-Fi link. I don't know. We directly use devices intercepting IoT protocols communications. We don't use encapsulated traffic, but it's a very good point to explore.
Maybe, yeah. Maybe
another question.
More question, yeah.
I had another question. Do you think it could be interesting on the graph representation to put different colors regarding the
protocol?
Yeah.
Yeah, it's a pull request I will do to make sure that we represent each protocol for the device to be able to separate some devices using different protocols.
Okay. And,
but it's a Neo4j configuration. It's a bit confused to use Neo4j.
Okay, I see. And yeah, my other idea was, or question was, do you think you can have something, the graph representation? Would you be able to have a graph representation that will evolve in real time if you add new information, like some kind of discovery, progressive discovery?
It may be possible as a future work, for examples, but as we treat each packet intercepted from each protocols, we cannot really have a live representation from the sniffing to the model. But I think the representation will be a bit delay from the interceptions. So for these demonstrations, I'm not able to make the demo for live sniffing and a representation of the networks, but I think it's possible.
Okay, thanks.
Is there any question? One more question in the audience? We have got 4 minutes left. Or maybe you want to hear more free license music.
Yeah, more free license music.
So no more question. Stop kidding, and no more question in the audience. Okay.
I may have one.
So,
yeah. Oh, sorry.
yeah,
I may have
Eric.
one. Did you consider to go for a dynamic model where you generate event? Like, oh, I got a new connection between two hosts that it never talked to each other before. Should I get an event that is warning me that something new is happening on the network?
Yeah. If we have some more data to IoT map, it will add some devices during the analysis of the data. So I think if a new device start communications, it will be represented in the graph. Yeah. But a new feature, I think it will a better response to your questions, is to make a time feature, a timestamp feature to the generation of the network. For example, we want to generate only the 21st minutes of the interceptions, and if a device did not communicate during these 20 minutes of interceptions, it will be not represented in the graph. And if we are focused on the 20 remaining minute of interceptions, sorry, it will be appear in the graph. So we just have to manage to add some timestamp to fix the analysis of the interceptions.
Okay.
Well, I think you managed to reach the time limit, Jonathan. With demonstration, live demonstration with question. It's perfect. So a last thank for your talk. And I am going to let Mathieu to introduce you our blue team time part of the afternoon. Mathieu.
Yeah, thank you. Bye-bye.
Thanks. Okay, so the next talk of the afternoon will be more about detection and defense against attacks. Next talk will be by Eric Leblond and Peter Manef from OISF. So they will talk about the rise of encrypted traffic on the internet and how IDS tools can be used today to try to detect attack patterns regarding this difficulty. And well, Eric and Peter, as you did not participate in the Zoom session test, we will completely trust you on your Zoom mastery. Thank you, and the stage is yours.
Okay, so Peter is going to start the slides and start the sharing. Peter, are you
here? Yeah, yeah, sure. I'm going to be presenting now real fast. Just 1 second.
Okay, so we see Peter.
You folks see me and hear me okay?
Yeah.
Okay, great. So you should probably see our slides here. That's coming up all right?
It's okay.
Yes.
Okay, perfect. So welcome to this talk. Eric and myself will be actually walking you through some slides, an actual hands-on example, how to hunt threats that use encrypted network traffic, more on the IDS and NSM part of the defense. First, a couple of words for us. I'll start with myself, Peter Manev. I am part of the OSF exec team, involved with QA and training. I'm also Chief Strategy Officer at Samus Networks, and it's OSF and via open source work with Suricata that I met Eric, and we became very good friends and colleagues. So Eric, I'll let you introduce yourself too.
Yeah, so I'm a developer at OSF. I'm a member of the executive team, and I'm CTO for Samus Networks, that is a company that is doing sales that we will be using in this talk, and product based on Suricata.
All right, cool. So talking about Suricata, what it is, you probably have heard about it. It's a basically IDS IPS network security monitoring engine, very high performance, multi-threaded scales, very good. It's open source software, of course. It's owned and developed by a non-profit foundation, the Open Information Security Foundation, and produces high-level situational awareness and detailed application-led transaction records, which we'll demo hands-on as well, especially when we're talking about malware using encrypted traffic. So I'll transfer here over to Eric, and then I'll come back to you folks when we're doing some hands-on, when we tackle some hands-on screens.
Yeah, so what we will cover here is basically what can we get out of TLS when we have TLS on the traffic. And if you consider a recent network, on modern network, you range from 50% of TLS to 90% of TLS, depending on the company. So that's really a big problem as for visibility, because all style IDS where you were just considering like a grep on the network to find some pattern, it will not work anymore because everything is encrypted. So we need to be a little bit more clever. So we will show you what has been done in Suricata to analyze the TLS exchange, get information out of it that can be used for threat hunting and for detection. So what we have is that we have TLS event. So we generate transaction for every TLS handshake. We have anomaly event where we detect something strange on a protocol. We got alerts based on TLS, and we got something that we will focus on, which is GS3 and GS3S. So client and server identification. Identification of the implementation, sorry. And for that, we will be using Sales for the hands-on part. That is a freely available and open source distribution that is providing you ready to use Suricata and interfaces. So TLS handshake, I think we have been, a lot of people here should know what is a TLS handshake. So that's the negotiation at the beginning of a TLS session. So it's everything that is exchanged before encryption, where they negotiate the public key, the cryptographic algorithm, this kind of thing. And so TLS, once it's switched to encrypted, if you are not doing interception, like man in the middle or things like that, you don't see anything. But you can see things in the TLS handshake, and that's what Suricata is doing. So what Suricata is doing is a handshake analysis. So it decodes the TLS message, it extracts information, and it outputs information in dedicated events. So for every TLS connection, you can generate a JSON event with all the information that Suricata was able to extract from the connection. So basic information are the subject of the certificate, the server name indication, the subject of the issuer DN, the fingerprint, that is quite useful to identify a bad certificate in the wild. And we can use this feature extraction to alert on this. So you can make a match on this TLS field to be able to detect some bad behavior or some bad certificate or some unwanted certificate authority, for example. And we can also extract on disk the certificate. So if you want to, you can modify an alert to say, oh, if I see that, then I want the certificate chain to be extracted on disk. And there is these two additional methods, GS3 and GS3S, that we will detail later, that allow us to identify client or server by its implementation. Basically, we can get a TLS user agent concept using the GS3. So here it is an example of TLS 1.2 event in Suricata. So the first field is the validity, and we've got the node before, then we've got the node after a bit below. And this is the information about the validity date of the certificate. And then you have the issuer DN, so the certificate authority that did sign the negotiation. And then you've got the GS3, I will get into detail into that later. Then after, you've got the not after, the version, the fingerprint, that is the same as you can extract from the browser when you connect to a website. If you ask Firefox or Chrome to display the TLS information, it will give you a fingerprint. So that's why you can use that. And you've got the SNI, the server name indication, that is really interesting because it's just it's in fact the host name of the box where we're connected to. So when you open the connection to a TLS server, there is this extension, the server name indication, where the client is asking, I want this website. So this was a fix that has been developed to address the fact that you can have multiple TLS server running multiple websites or multiple TLS service on using this. It is using this mechanism to know which certificate to return. And then we have got the subject, which is the subject of the certificate, so which site it is supposed to be used on. So you have seen that we got a lot of fields that are extracted from the Suricata event. And then we've got keyword from the Suricata language that we can use to say that we want to match on some specific field to find information and to generate an alert from the IDS part of Suricata. And then this alert will be handled by the analyst to see if we have a problem, if we need to trigger incident response. So for example, the first example I give is you want to check that your super over expensive PKI is used correctly in your network. So one way to do it will be to connect on all the server and check that the TLS properties of every software have been correctly implemented. Another way is to do it passively with Suricata, where you just say, I want an alert as soon as the cert issuer, so the certificate authority that did sign my certificate, is not the one from my company. So this will trigger an alert, and then you can just handle the alert, and then we know, oh, this server is not using the correct certificate by the correct authority. So it's really useful, for instance, to detect a wrong certificate here. And another one that you can do is also, if you want to avoid man in the middle or interception, you can set up an alert to say that you want the self fingerprint, so the certificate fingerprint, to be checked against a value, and you get an alert as soon as you don't have the fingerprint for your specific server. So if somebody is replacing the server, you will automatically detect that from the IPS. Yeah, so now I end up the key.
So we'll be talking a little bit on about what you actually have in that in such alert. So you should probably see my screen, all right, folks? I hope you let me know. Eric, does this come up all right?
Yeah, it's good.
Okay, so for example, let's just pick up, this is a threat hunting interface as part of SELKS, is called Sirius. And if we actually zoom in on, for example, we want to look at strictly what do we have in terms of JA3 hashes and that encryption connection. So let's have a look at an example of an alert where, so for example, this is one traditional Suricata alert, I would say, where you actually have information not only about the source and the destination of IP, you can also have different informations, like, for example, the whole flow, packets to server to client, and the TLS information that we're talking about. So actually, here is our JA3 hash that we have in here. So basically, there is a lot that you can still do with that information, because even if you go encrypt it, it starts first with clear text, and during that exchange we can have that hash. Also, what is very powerful is as part of the flow, we have the so-called flow identification, and all the specific logs from a particular session or conversation, if you will, share the same flow ID. And in this case example, you can see that besides the alert, we also have the actual TLS record, and all the information that Eric was mentioning about is in here too. So it's really easy to kind of relate that info in there as well. There is also something that is called community ID, and that allows for cross matching of flows between Suricata and other systems as well. So anyway, just wanted to show you, we wanted to show you the actually usability of it and how it can actually come into play with this quick example. Eric, back to you. Do you hear me okay?
Yeah, it's
okay.
Sorry, I was mute.
No problem. So we're going to switch over to some rules, yes. I suggest, yeah?
Yeah. So the first one that you have seen, that Peter did show you, is expressed like the first colorized screenshot on the top. So it's the one that will identify the demo certificate, because yes, the bad guys are lazy. So in a lot of cases, they just use the default configuration in OpenSSL to generate their certificate. And as a result, you will have this basic internet widget PTY LTD that is seen on the traffic, and it's or some poor admin that is working for your company, or it can be an attacker that is really lazy. And another usage that we can have, and we'll get into detail to GS3 just after that, is the GS3 phishing. So it allows us to identify a server implementation. So in this case, we for instance, we've got this signature, GS3 hash for banking phishing, that detect a phishing website, a phishing site, sorry, based on the implementation that is used. Next, please. Yeah, so there is some existing signature lists that are available publicly. In some cases, you need to pay for them too, for AT Pro, that contain really interesting usage of TLS. So for instance, 1, 2, 3 interesting one are abuse.ch that publish fingerprint of non-command and control from malware found in the web. So that's quite useful to identify bad communication because they are bad because you are going to CNC. So that's quite useful. And you've got, so it's based on the fingerprint. So they find the individual certificate, and then you got the GS3 that identify the server implementation. So it's also an interesting list. And then you've got, we'll show you some example TLS rules and GS3H rules that are also available in TOpenRT Pro, and that use this feature of the feature of Suricata that analyzes the TLS on check. The TLS GS3 algorithm, as well, I've always forgot the name, but it has been invented by 3 people where their initial are GA, so that's why it's called GA3. So don't look at some algorithmic explanation of the name. It's just because 3 people with initial GA did invent the algorithm. So what they did see is that the way the negotiation is done at the beginning, it starts with a client message, and this client message has some characteristic, and if you take them, it's really possible to detect and identify the implementation. It's always a little difference, and this little difference they can be seen in the certificate. And yeah, so this. We got the, excuse me, 1 second. I've got a technical issue.
Maybe I can cover a little bit while Eric comes back. So
good news outside.
Yeah.
Just your bet.
Okay, I hear you loud and clear now. You're right.
Yeah, I'm right. So there was a vacuum cleaner going, so I was. Let's fix that. Sorry for that. And yeah, so and there is a yes, and we can also do the GS3 server side for the same within the same methodology, but it's less. We see that there is some problem with this one. The good thing with that is that it's compatible with TLS 1.3, so we can really use it even with TLS 1.3. So the GS3 example, we are taking the same example as before. So we have the GA3.string that you can see starting with 771. That is a long string, and in fact, it's just a series of parameters using the identifier of the message in the TLS connection. And this one is the one that it found as significative to identify the TLS implementation. And using this, they produce a hash version that is a little bit more easy to read. That is there, that is just hash version of the string. So by using that, we're able to identify the implementation. And for the GS3S, we've got the same thing. It's a little bit shorter, and the string and then the hash. What you can do with this hash, so we have seen previously that you can identify bad client implementation, and you also can do a mapping. So come from this GS3 hash to a user agent name, because this way you can identify Firefox 64 or Chrome 32. Or 33, and by using this mapping. So that's quite interesting to identify your resources in the network, because you get to a real software name. And you can also detect bad GS3 hashes. And one of them is published by abuse.ch. And you can also use Suricata to generate, thanks to the dataset option. We will not go into detail into that, but you can generate clean list and alert list that you can use to generate event and alert based on hash that you know are good and hash that you know are bad. So the GS3S is the server side of the GS3. So it takes another set of fields, but as I said before, what is happening is that the server is answering to the client. The client is the first one to send the message. So because of that, the context of the message that are sent by the server depend on the client. So in fact, the GS3S is not unique for one server, and it depends on the type of client that it connects to the server. So you got unicity for the same client implementation on same server implementation. You don't have unicity for just one single server. But that's quite useful because if you have a malware that you know that connect to the same command and control, then in this case, you will have every time the same client on the same server, so you can identify correctly a malware system. So I'm not a WireGuard developer or some OpenSSL on TLS guru. So I will do short on TLS 1.3. So from a Suricata standpoint, it's just a nightmare because they did improve privacy a lot and try to prevent interception. And the most effect that we see in this is that almost all the handshake is encrypted now. So we don't see a lot of things that we were seeing before, like subject issue at the end is not available anymore. We can not really, we get really far less information. But what we can do is still we can hopefully we still have the GS3 and GS3S working. We still have the server name indication, so that's quite useful, still useful. So we can see which site we are connecting to. So we still have some information. And so what we have left is just GS3, GS3S, the server name indication, but there is a draft about removing server name indication and moving it to the encrypted part. So that would be kind of a drama if it happens for us. And but what we will have left anyway is the flow entries. Suricata is able to produce NetFlow-like data. So by that we mean for every connection, TCP or UDP, we have the volumetry in and out on the port source, the port destination port, the IP source, IP destination, and some other information. And we can use that to find things. So in a lot of cases, the people that are doing machine learning on network data, they are just using the flow because it's always there, it's convenient, and there is a lot of numbers which are easier to handle from string. So they, in a lot of cases, we are using that. Yeah, so a flow entry in Suricata is looking like that. So we have a typical thing that we have. Source IP, destination IP, and then we've got the volumetry in terms of packet, byte to server, the start and end date to know how long the session was. And we've got, in case of TCP, we've got information about the TCP flags that can be used to see in which stage of the connection we were. So that's something that is quite useful.
Wow. All right. So I suggest we have a few minutes left, so let us allow us folks to walk you through a quick demo of different angles that you can use for hunting and encrypted traffic. And I'm going to switch over to one of the SELX interfaces here. SELX is basically as database uses Elasticsearch, and so Suricata produces a lot and different types of logs. So for example, so it's not just about alerts. It's about being able to correlate that information, different protocol breakdown. So anything and everything there. For example, HTTP, RDP, RDP, SIP, DNS, TLS, SSH, all those protocols can, all the information there and the logs can be there even without Suricata running, without any alerts, without any IDSing, if you will. But the combination of those actually makes it real good for kind of hunting and network security monitoring, as it combines, you know, the IDS and the actual log views from the network. And in this case here, we actually loaded detonated pickup from TrickBot. The pickup is available. You see it at the end of the slides, where you can download it from and reproduce the exact same thing yourself. So what we're looking at here is basically the TLS protocol breakdown for that specific detonation, if you will. And in that specific case, we have about 980 logs. And what does this mean? So it gives us a basic overview of, like, you know, TLS versions, the subject name identifiers, you know, issuers, geo IP locations, similar things. So Suricata can detect TLS regardless of port. So you can see here how you have the traditional 443 port, but you also have others, source and destination IPs. And here is actually where, for example, the JA3 and JA3S hashes come into play. So a very easy way to pivot around those. And if you look, so JA3 is on the client side, JA3S is on the server side, as Eric was describing. So you can basically sort through anything and pivot, and you'll see that, you know, the same basically JA3 server kind of hash is present for all sorts of different public IPs. Basically means that this is same application running on the server side, at least in terms of encryption. So we actually, if you want to zoom in on that, let me just confirm that. So something interesting begins to happen. You see how you're starting to see more and more of a kind of the traditional expectation of beacons, but they're not all the same. And I want to just deep dive a little bit into that and show you around. So you have five different public IPs with different counts. You know, there's smart people everywhere, not just the good and the bad, not just the good, but the bad as well. And in our case, like you might keep wondering what's one and what's the other. Why do we have a bigger count here and a lesser count there? And here I'll show you an example of a flow, of a log record for TLS. And in this case, you know, we have the community ID, some other information, including GeoIP. We also have all the TLS meta information about that connection as well. And it's very easy to pivot out of this. For example, you can click on correlate flow, and that will bring you to Evebox, which is developed of one other Suricata team member, Jason Lish, where actually, as you can see, this is correlating on the actual flow ID here of that specific log, or in other words, this is this ID number here. And so it's an easy way to pivot out and see, oh, okay, this is the same flow, what else has happened? And you can see that there is an alert here, a TLS record, and some flow records. As well as that, you might as well be wondering, so if you are looking at the alert, and this is the SSL demo, that's actually, if you go back to the hunting interface, this is the actual alert that actually ran, and you can see, of course, some patterns in here. But what I wanted to bring to your attention is, like, if you look at all the different signatures, there is a bunch of different stuff that rings in. So it is encrypted, and you can definitely come up with a pattern. You can definitely come up with verbosity, but there's other hints there that will show off, will give us a major visibility to what's happening. And those hints are actually all the different alert metadata, if you will, that is provided by Suricata, and even much more massive availability on it when it actually provides more things like correlation of the same flow, of user agents, and similar things. So here we have all the TLS information in here, including issuer, subject, fingerprint hashes, and similar stuff. And other hunting angles that you can use, we have these so-called preset filter sets. And what's interesting here, what I wanted to show you about these different beacons is actually, you might as well sit and wonder, you know, why are they there? And I'm clicking here and, because what I wanted to show is, like, we have different GeoIP where this GeoIP locations where this is going, you know. And in that case, while we were investigating, we find out interesting things. If you actually look at the alerts themselves, so let's have a look at the first one, okay? So we have a generic post. So that's post-infection, but that's where we can detect them as well. So apparently it went through all defenses to go to post-infection. And here I actually have a, so apparently OpenVPN passwords and configs are being extracted from here. And this is actually all data generated by Suricata. So the payload printable, the request body, the the response body. So what this means is actually this public IP here actually wants to know about all open VPN passwords and configs. And if we go to the next one here, rather this one, sorry, let's have a look what's in here. This one actually wants to know about open SSH private keys. So that's the task of this IP, let's say. And then on the top one, we have a different collection mechanism, or a different collection that specific IP is interesting. So coming back onto the TLS itself, actually, it really, it's a perfect beacon size. You know, they're trying, as I mentioned, there's smart people everywhere. So they're trying to, you know, get different volumes, different intervals, different counts and all that. So it will make it much harder and harder to detect. But the unescapable truth is that it needs to start with a clear text. You cannot start encrypted right away. It just can't. So it needs to start with a clear text or a handshake somewhere, and then some part of the exfiltration or other stuff is also clear text. But with respect to JA3 and JA3S, you can actually do a lot. You can actually do graphs, detect new JA3Ss that or JA3 client hashes that have been there, and you know, map them out and see what's new in the network today that wasn't there yesterday, for example. And similar thing. I just wanted to show you the correlation for the full blown, you know, detonation of this TrickBot, of which TLS is part of, you know, mostly for command and control or beacons rather, but there's also other aspects of the different levels of the attack involved. But TLS, even though it's entirely encrypted, even though you don't need to look at any alerts, you can discover a lot just by, you know, correlating different data, you know, JA3S versus JA3, you know, what's new, what's old, what's not traditionally seen on your network, and similar stuff, where you can actually tell a lot. In a similar fashion, Suricata also provides anomaly events that will actually tell you things like, you know, protocol in only one direction, or unable to match response to request. And this will also detect any specific anomaly in the encryption layer, in the encryption part as well. So there's ways to do it without entirely being reliant on rules and alerts, which is not bad, but the combination of rules and alerts with the logs, with the other NSM logs that were produced by Suricata, all that combination allows for actually a pretty good network traffic analysis hunting exercise, as we were mentioning here, here in this case. And again, it could very well be revealing just by looking at TLS records from the different aspects of the network and correlating that back and forth within the 24-hour period. Eric, anything I've missed to cover? Because we're running actually short on time. I'd love to talk about that, and we can do a full day workshop actually, which we should do. But Eric, something I maybe forgot to answer, or anything to add?
If you can just get back to the end to show that, in fact, even if it's some kind of, just go to the dashboard and we have remove a filter. What we have is that in a lot of cases, we've got multiple alerts, like OpenSSL widget compared to the abuse CH that did trigger too. So yes, you have multiple alerts on SSL that did detect this TrickBot attack. That was in fact really a case where the data are coming from one TrickBot sample that has been run on a virtual machine, and then we did capture the traffic. Josh did capture the traffic, and that's what has been used here. So that's a real traffic from the TrickBot. And as you can see, that's something that we can detect through signature, and we can analyze and find things even if there is no signature via what Peter did do. So I think we can jump to the conclusion.
Yeah, the combination of those is really powerful, like regular traditional logs plus the alerts together. I think it's really cool. I'm going to switch back to our slides here. Conclusion. So TLS is, of course, a serious challenge. Visibility is decreasing, but there's ways and things you can do about it, including analyzing encrypted traffic, including looking for anomalies, including better positioning your sniffing devices and all that stuff for different parts of the network, you know, behind load balancers, proxies, front, behind, and similar things. There's ways around to do it and play with it, including modern gateways and firewalls allow to decrypt traffic and pass it over to a sniffing solution as well. The PCAP itself is located on the link provided. It was done by Joe Storstein, who is actually Director of Training at OISF. He actually did a detonated catch of the PCAP. Please welcome and join the Forum Suricata and ask all our user base for help or any exchange of experience. We'll be happy to actually help out anytime we can. There are Suricata trainings and webinars. You can visit the suricata/ids.org training to learn more, to have more information about those. And of course, you can download SELC 6 and try it out yourself. Actually, the PCAP is there and the SELC 6 is there, and actually you can see how. So one of the peculiarities about SELC 6 is that any and all data there is produced entirely by Suricata, not by any other tool. So you can actually play around with it as well and have a look for yourself as well. I think we're open to Q&A session at the moment, right? Any questions or feedback is welcome. Actually, let's see.
Thank you
very much.
Thank you.
There is, there are several questions in the QA system.
Yeah. So first one, I take it. Do you support ECS schema in Sirius Ifbox dashboard? No. Sorry. I'm going to be straightforward on this. No, it's not planned. I think there is already transformation provided by Elasticsearch. So they provide a module to convert Suricata event to their format. And we're not going to change the format. It's not planned. Maybe in a few years, but not short term at least. Second question. I'm not sure if I have understood. You are just inspecting TLS itself, not the encrypted payload. Yes, we are inspecting the TLS on check, just the negotiation of the encryption at the beginning when it is in clear text for TLS 1.2 and 1.3, it's encrypted. But we can use the information on, yes, you can do interception by combining Suricata with some other tool that do man in the middle on things like that. So you can do, you can go clear text. That's really a political choice, but you can do it. But you need some other tools. And okay, so we've got an anonymous attendee with a vicious question about is the entire certificate pairs unextracted by Suricata? Answer is yes. Can you make any check on expecting certificate extension or their values? Not currently, it's not yet available, but we are doing the parsing. So it's not a big code on OISF is really community oriented, so patch are welcome. And the end of the question, what about all the certificate chains? So we are doing the parsing of all the certificate chain, but currently the match is only done on the first one, if I'm not mistaken. Peter, did I see crap?
No, I think you're good.
Okay. Yeah, so now currently now it's just the first certificate and we don't get down and but it will not be too complicated to get down. Yeah, that's it.
One more question. Do you know regarding the GA3 method, if it will still be reliable with the evolutions of TLS and with the much shorter negotiation phase?
Yes. So if you in TLS you've got the TLS 1.3, you've got this capacity to take TLS in the middle, and you also have got that in TLS 1.2. So it's really faster to do the negotiation, and in some case you can resume a TLS session. So in this case, no, it's really a problem, and we just see that it's TLS and that's it. We can't do more.
Yeah, okay. And finally, the dashboards that you presented in the various tools and in Elastic in particular, they are shipped with cells.
Yes, they are part of Cells. Peter, they are available in a separate repository too, but they are part of Cells. Yes, it's part of Cells.
So you have both cases. One is the ready to build and distro, and then the other one, they're standalone as well. Underneath the Starmouth Network GitHub repo, you'll see them. They're called KTS7 for Elastic, for the X7 stack, or you can use them standalone too.
Okay.
And any suggestions or contributions to those are more than welcome. Of course, we'll be happy to add them in.
Okay, well, thank you. I don't think there are any more questions, and so it will be time for a little 10-minute pause, and then we will resume the afternoon talks with 2 more talks for the end of this session. So thank you, Peter.
Thank you very much for the time.
Thank you. Bye-bye.
Bye-bye.
Okay, so we are back for the next tool talks and the last two talks. So next talk is by Peter Zanik. He will talk about how to use syslog-ng and in a more general way how to create a log chain from the log collection to the log analysis. So every step will be detailed. The stage is yours, Peter.
Thank you. Can you hear me?
Yes. All right.
So a few words about me. I'm Peter Zanik from Hungary, open source evangelist at OneIdenti, syslog-ng's upstream developer. I'm doing packaging support advocacy. So what I will be talking about today. First, I will go back to the basics. I mean to central log collection. Even now, it cannot be everywhere to get for granted. Then I will talk about how complexity grows together with your organization and how log management becomes more and more difficult and how you can reduce this complexity using a dedicated log management layer. And then as a syslog-ng guy, at the end, I will show you how to implement it using syslog-ng. So first of all, let's go back to the basics. Even in larger companies, I often see that there is no central log collection implemented or just some very minimal for some of the servers. Which is not a really good thing, as we know central log collection is the basis of log analysis, and we are not interested only in the main servers, but we only know about our security and infrastructure if we log everything. So let's talk about a few words about central logging and why is it so important. First of all, it's ease of use. One place to check instead of many. So you don't have to log into each of your system to figure out what happened, but check a center log repository. It's also availability. Even if your sending machine is down, you can still check your logs centrally. And it's also security. The first thing when a machine is compromised is to delete or alter log messages. But if they are already sent to the central location, then you can check them there. And obviously, if you want to analyze your log messages, then you also need to collect them centrally. But as your company grows, complexity grows as well. People start to use multiple analytic systems, and that way also waste quite a lot of resources. A proposed solution for this problem is consolidating the system into a unified log management layer. So once your system, once your company or organization grows, you will have more than one type of person there. You will most likely have security, developers, operators, and probably a few more mixture of these guys in your team. And all of these use log messages. They analyze them, but they have quite a lot of quite different tools. The problem is that all of these analytics tools come with usually with their own log aggregation tools. So here are some examples. Elastic comes with Beats and Logstash. Splunk comes with forwarders. Most SIEM systems have their own log collectors, just as logging as a service providers. these are most of the time on top of local syslog collection. So you see here for the Elastic Stack on top of syslog, they have Beats, then Kafka or Redis for message queuing, then Logstash, and finally Elasticsearch. But also SIEM or logging as a service software creates an additional layer on top of the existing log management. Why is it a problem? Because the more software you use, the more computing resources you use. So if you have 3-4 different log analysis software and their collectors installed on each host, then it can waste quite a lot of computing resources. But it's just a smaller problem. But for example, if your systems are in the cloud, then you are often paying for network bandwidth as well. And sending the same data over the network multiple times can be pretty expensive. It's also more human resources. Just think back on the previous slide that getting logs from the host to Elasticsearch can take up to 4 different software to configure. And it also might mean more security problems, as if you have more software, then there is a better chance that there is some security problem as well in them. So this is why it is recommended to change to a unified log management layer instead of using many different log aggregators on your systems. It saves you on computing, network, and human resources. It's also easier to push through security and operation teams, as they have to check out a single software instead of 4 or 5 different applications. This way you can separate log management from analytics, which means that you can easier replace either components on your system. And as an added bonus, if the analytics solution you use is based on the amount of data, then you can save quite a lot on licensing and hardware costs as well. On the next slides, I will show you how to implement log management based on syslog-ng. First of all, a quick introduction to syslog-ng and its 4 major roles. Then a few words about modes of operation. And finally, I will show you a configuration of syslog-ng. So, what is syslog-ng? It's an enhanced logging daemon with a strong focus on portability and high performance central log collection. It's originally developed in C, which is good both for performance and portability, but it can be extended in Python and Java as well. The first major role is data collection. This is what I already mentioned earlier, that if you have a unified log management layer, then you can use the very same software for collecting system and application logs together, which can provide quite interesting contextual data for either side. Syslog-ng supports a wide variety of platform-specific sources like devlog, journals, sunstreams, and so on. As a central log collector, it knows both the legacy and the new syslog protocol over UDP, TCP, and encrypted connections, and can collect logs or any kind of text data from applications through 5 sockets and so on. And we also have now Jolly Joker, a bit slower than implementing in C, but a lot easier to develop. It's you can write source drivers in Python Some examples are HTTP servers like the Splunk HTTP event collector or the Kafka source, and quite a few more. The next role is processing. You can classify, normalize, and structure log messages with built-in parsers like CSV parser for columnar data, PatternDB for unstructured data like an SSH login message. But we also have JSON, XML, key value, date parser for some esoteric date formats, and so on. Syslog-ng can also rewrite log messages, and you don't have to think about falsifying messages here, but for example, anonymization was needed by quite a few compliance requirements. You can also enrich data, like adding geolocation based on the IP addresses or additional fields based on the message content. And we also you can also extend Syslog-ng here using Python. You can implement any of the above features in Python or enrich logs from external databases, and also do filtering from Python, which brings us to our next topic, data filtering. It has two main uses. Both of them are very important if you have central log collection and forwarding log messages to different analytics softwares. The first one is discarding surplus log messages, like not storing debug level messages. The other one is message routing, making sure that all relevant information reaches the right destination, like, for example, all authentication related events reach your SIEM system. There are quite a few possibilities. It can be based on message content, different parameters. You can do comparisons, many different filtering functions. And best of all, any of these can be combined using Boolean operators. Finally, you want to store your log message, store or forward your log messages somewhere. Traditionally, syslog messages were collected into flat files, and this is still the most used format for long-term archiving of log messages. But you can store logs to databases, to different big data destinations, Elasticsearch, and forward to different log analytics systems as well. If an destination is not yet readily available, there is a good chance that you can create your own based on the HTTP destination. That is what we use for Splunk or Elasticsearch, or you can code it in Python or Java as well. Most people know only two modes of syslog-ng operation: the client mode and the server mode. The client is sending the log messages to a central location, and the server is collecting log messages. But there is also an third possibility. It's called the relay mode. It's an intermediate. So you can your clients can send log messages to the relay, which collects messages from a department or a geographical location and forwards it to a server. Why relays are so important? For example, if you have a UDP source, you want to collect these log messages as close to the source as possible. So if you have an old router or switch or other networking device, you want to have syslog-ng collecting these messages as close to it as possible and forward it to the central server using a more reliable protocol. It's also scalability. If you have many hosts to collect messages from, then you can distribute parsing and filtering of these messages to the relays, and it also gives structure to your network, so you can put a relay to each of your departments or each of your geographical locations and collect log messages there and forward to the central server. It can be quite useful, for example, if you have your network down or the central server down for maintenance, as log messages are sent from the hosts even if the central server is unavailable. Let's talk a few words about log messages. If you take a look at your var log messages, you will find many similar messages like the one on screen. It's an SSH login message. And you will see that it's practically a date, a host name, and some text after it. That text part is an almost complete English sentence with some variable parts in it. It's pretty easy to read by a human, but as soon as you want to create alerts or reports on it, or want to decide to which analytics tool to forward this message, you will have difficulties as you don't really know what is inside. It's easy to read by you, but not easy to act on it by a computer. The solution for this is structured logging. If we come back to my SSH login example, you see that it can be described as a application name, username, and the source IP. The good news is that syslog-ng has name value pairs inside right from the beginning. The date, facility, priority, program name, and so on were all stored as name value pairs inside syslog-ng right from the beginning. And parsers of syslog-ng can turn unstructured and some of the structured data into name value pairs as well. Why name value pairs are so important? Because they can make filtering a lot more precise. If you just see that it's an SSH, it's a message from SSH, then you don't know much about what is going on. But if the message is parsed and you see that it's a login by root, then you can act on this message and create an alert, for example, to receive an email or a Slack message as soon as root logged into somewhere. When it comes to configuring syslog-ng, my initial advice is always don't panic. It's simple and logical, even if it looks difficult at first. It has a pipeline model with many different building blocks like source, destination, filters, and so on. And these building blocks are connected into a pipeline using log statements. On the next slide, I will show you a very basic syslog-ng configuration, which is good for var log messages. And then I will show you a configuration for centrally collecting and processing log messages from Suricata. So that's why I'm quite happy that I'm coming right after the Suricata presentation. Here is a basic syslog-ng configuration. As you can see, it starts with a version number. Then you can include external configurations The first one here is scl.conf, which stands for syslog-ng configuration library. It has lots of good configuration snippets in it, doing some magic work like finding credit card numbers in log messages and masking them, and or parsing pseudo log messages and or Cisco devices log with pretty broken message format, and this using SCL you can still parse most of the Cisco log messages. So there are quite a lot of interesting stuff included. Obviously, you can comment your configuration options is for configuring global options. So if you want to configure something globally for all of your sources or destinations, that you can set here. Next, we can see a bunch of building blocks, a source, a destination, and a filter. And on the fourth row, you can see that there is a log statement which connects all of these together. So a source for local log messages, a filter, and a destination for var log messages. At the bottom of the screen, you can see another include. This is used in most of the syslog-ng packages now, so that you can easily extend the syslog-ng configuration without modifying the basic configuration. And this is what I used for Suricata. It's an additional configuration in this directory. Suricata logs in JSON format, and here I have an TCP source listening, and it has a flag called no parse, meaning that the incoming log messages are not parsed automatically by syslog-ng, as it expects syslog messages, not JSON. So here we disable parsing, and on, at the bottom of the screen you can see another parser. It's a JSON parser, which is parsing the incoming JSON messages, creating name value pairs from it, and all of them have the Suricata prefix. Here we do some geolocation magic. At the top of the screen, we see the GeoIP parser, which takes a name value pair containing an IP address and creates a new name value pair from it using the GeoIP parser. At the bottom of the screen, you can see a rewrite rule. This one is used to change the geolocation into a format which is understood by Elasticsearch. Here we define two destinations, one for local archiving of log messages in JSON format, so we have all of the name value pairs, but not just the one coming from Suricata, but also those which we created through message parsing, like GeoIP. And at the bottom of the screen, we see an Elasticsearch destination using the very same JSON formatting. Here we can see a few additional possibilities. Python, we define here a Python parser. We will see the code later on. And at contextual data can be used to add additional information fields based on the message content. So here we have list. We take the source IP address as a data selector, and based on that, we add a few more information from an external CSV file. It can be, we use it on local IP addresses. It can be good, for example, to add a room number or rack number or administrator name, or whatever you want to add to speed up investigation. Here you can see the Python code. Shorter code can be included within Syslog-ng as well. For longer one, it's not really recommended. But for short, it's pretty easy just to enter a few lines. In this case, it's resolving IP addresses to host names. And here we have a log statement. It's quite a long one, as with recent versions, it's easy to add additional logic, not just the source, filter, destination, but a lot more. So what you see here, that we have the Suricata source, what we defined earlier, we reference it from here. Then the JSON parser is referenced. And next, we use the Python parser, but only for those IP addresses which are not local. This is a simple filter on on an IP field. So if it doesn't match 122.168, then we consider it as external, and we use the Python resolver. Next, we use the add contextual data on local IP addresses, which I've shown you earlier, that it's using an external CSV file. So you can easily add additional fields based on the IP address in this case. Here, I show you another filtering. It's checking the TLS information from the Suricata logs, and if it's matching /.org, then it's writing to a separate file, but it could be sent to an SMTP destination, to Slack, or wherever you want to receive real-time alerting that one of your user is reading something what he shouldn't do in work time. Syslog-ng can also do black and white list filtering. Here I added a filter which is checking an IP address list of malware control and command and control machines. And if the IP address is matching, then it creates a name value pair with the content of saying problem, else it writes OK as value here. You can use it for alerting or create an table in Kibana or whatever you want. Next, we reference the GIP parser and the rewrite rule. And finally, we store log messages both local to the local file destination and to Elasticsearch. And here is a screenshot from Elasticsearch. the GIP results of the GIP parsing can be seen here. So as a summary, using syslog-ng, you will get high performance and reliable log collection. You can greatly simplify your logging architecture, as you can use a single application for collecting both local syslog messages and application data. It's also easier to use data, as messages can be parsed and presented in a ready-to-use format. And syslog-ng can also greatly lower the load on your destinations by efficient message filtering and routing. If you became interested checking out syslog-ng, our website is syslog-ng.com. The source code and issue tracking is on GitHub, and you can contact developers and users on our mailing list, and also on Jitter if you prefer chatting. Do you have any questions?
Okay, thanks for your talk.
Thank you.
So well, we have no question in the QA system for at the moment. I do have one question right now. So my question is, in syslog-ng currently, are there a lot of parsers that are implemented and available? For example, for I don't know, classical Linux logs or things like that.
There are quite a few parsers. Where to start? I don't know all of them from the top of my head. One of the oldest one is the CSV parser, which I mentioned. That's good for anything columnar data, like Apache command log or similar log messages. Then we have PatternDB, that's for regular Linux or Unix log messages. That's for freeform text. We don't have too many patterns in that one, but if you have log messages, we can help on the mailing list or in Jitter to help to write you one for your specific log message. Then we also have JSON, XML parsers. We have many different parsers for different network devices, as most of them mess up the syslog format and try to do syslog, but they do just something similar. But we can correct those mistakes by combining these parsers. So there are quite a lot of possibilities.
Okay, and so for example, it would be possible to have like an XML source and to transform this to a JSON message to forward it to Elasticsearch, for example?
Yes. I'm not 100% sure if all of XML is implemented. I mean, I recall that there are some parts of XML which currently are not yet possible to be parsed correctly by syslog-ng, but most of it. And then you can simply, as it's parsing XML, it creates name value pairs, and from that you can create the JSON on the output side. So yes, it is possible with some limitations.
Okay, okay. Voilà. Don't think we have any more questions right now. So, well, then thank you again for the talk.
Thank you.
And then we'll just have a quick pause, waiting for the right time to start the next talk. Okay, so we will have the next talk now, the last talk for today. So it will be by Philippe and Thibaut from the CrowdSec project. So they will present us this project, which is about trying to have a better sharing in terms of attack detection and attack patterns and reaction to attacks. Okay, so everything set up.
Yes, I think Philippe has a connection issue. I'm going to take the.
It seems to be a bit better. If it ever fails, I'll switch to Thibaut. I'm very sorry about that.
Okay, well, right now we can hear you both, so
Sure.
you're right, and we have your presentation. Okay.
Thank you for having us, first of all. I'm really delighted to make our first Spice Assault. Thanks for the team selecting our paper. And we're very, very proud to introduce this for the first time, actually in an open community environment. It's about CrowdSec. It's about a new product that is secure. Stop my video, sorry. Yep. You don't see my slides, right?
We do see them, yes.
We do. Yeah, it's okay. You're sharing right now.
Okay, so yeah, so sorry. So the product is about security, right? It's about having a global security system, network worldwide, with a lot of participants that will help secure each other, okay? So let's see a bit how it works. So first of all, the problem is known to everyone, I guess, in the room. We have a problem when we are CTO, CSO, whatever your name on the card. You have a time problem, the time between, you know, where the 0 day is out on the market and the moment where you get compromised. The moment where you get compromised, the moment where you detect the hacker, and so on and so forth. So the time is always against you. And besides, you don't even choose when it starts. It's the hacker choosing when it attacks you. Then there's a problem of apps. You know, there are a lot of ports that are just unfiltered, like, you know, web ports, apps, mails, DNS, and so on, you name it. You know, it's not a problem. There's a lot of ports. Actually, there are more ports that are unfiltered compared to the filtered one. There's the perimeter that is changing also a lot. So with cloud and shadow IT, you don't really know where is what, when things are happening, when your people are publishing code and where. And besides, now with this COVID crisis, we have like an extension of the perimeter. I mean, people are bringing literally their home network at work. So when someone is playing on a PlayStation and the little one is looking on internet, whatever, and you know, and everything is happening at home, and you bring this to your company somehow through VPNs and so on. So it's really not cool. The perimeter is changing a lot, and money, obviously, because the people that are attacking you are using free resources that they stole, free tools like open source tools, and their time. So basically, it's nearly free for them to attack you. So these four cogwheels are really the main problem we're trying to solve here. How do we do it? It's pretty simple, actually. We want a solution to be real time, obviously. We want to be reputation based. So we don't trust an IP because it's coming from a known range. We trust an IP because it has not done crap for the last 72 hours, for example. You want to decouple detection and remediation, like things are in very modern architectures. You have very complex systems, and you don't want, maybe your logs are stored on one place, and you want to remedy the problem at another place. So you want it to be loosely coupled. Then you have the behavior assessment. This is what we'll see just right after. So it's both reputation-based and behavior-based. And we share with the crowd all the findings. So this is where it's really open source minded. You will see we share everything we find all together so that we are all together more secure. If you want, I mean, we have a very louse parallel, which is like your parents used to use the left-hand map, and we want to do what Waze did with the map, you know, like this. So basically what a firewall does, everybody is very familiar with this, it does just basically filtering ports, okay? It's about like ports, ranges, IP source, IP destinations, and so on and so forth. It's mainly this. But then on the right-hand side, what we do is we do filter behavior. So if we see someone trying to do brute force, for example, okay, we'll deal with the brute force. Or port scan, or web crawler, or exploit, you know, we try to identify the behavior and not a fixed pattern of a firewall. And how do we do that? Actually, we take your logs, the logs you want to share with the system. You receive constantly a bad IP list, a block list, you know, of people that we know are malevolent or attacking your connection, or attacking your IP, or attacking your technical stack. We take, for example, trace from your CM, cloud trace from your cloud, or third-party connection. We could take any source of data you want. Then we use a scenario that is written in a very simple manner in YAML. Actually, it's a very descriptive language, very easy to write yourself. So there are our scenarios, the community scenarios, and your scenarios that you might want to write. For example, say you have a customer, he's doing e-commerce, and he's warming up his cache. You know, he's crawling his own site to warm up his cache, but he forgot to update his system, and he's triggering 404 himself. Okay, not a problem. We know about it. You can put it in your scenario, so you ignore that. It's not a problem. You can use then remedy you want the way you want. You can block if you want, just simply. You can use a CAPTCHA, for example, if you're using a web layer or an app layer. Instead of just blocking, you can just send a CAPTCHA. In case you know you think this IP is a large NAT network, it could be useful to not block everyone. You can limit rights, for example, like say, you don't have the right to access /admin because you've been looking for troubles with /admin for a while on many different IPs, so we don't trust you to access /admin. Or you can say, for example, send a multi-factor authentication because we want to be sure it's you, right? And then once you found something that is potentially a problem, a problematic behavior, you share this IP with the rest of the community, saying, okay, this IP has been doing aggressive crawling toward me. I blocked it. You may want to block it as well. And more than anything else in the world, we all like demos, right? Thibaut has put together a demo for you, and then we go on with the flow of the presentation. But demo is, you know, the pinnacle of the theme somehow.
Thank you. Can you stop your screen share so I can take
it? Sure. Stop screen share. Stop share.
Okay. Okay, you should be seeing my desktop normally. So this is good. Okay, let's demo good. Be with us. So the idea is to demonstrate the setup and the usage of CrowdSec. It's an open source project, and one of the things that we are really committed to is to try to have a software that is very user-friendly. So to show this, we are going to demo the setup and usage on a quite classical Linux setup, which is like a Ubuntu server with a Nginx and a SSH server. So of course, everything that can be done in an interactive fashion can as well be done without interaction. We are not savage, but what says is this setup more than a wizard. So the idea of the wizard, and this is why we take a bit from software such as fail2ban when we say processing log. First of all, it's going to try and detect the software that are deployed on the machine, so that the out-of-the-box configuration will be relevant. So here it detects that I have Nginx web server, SSH server, and that it's a Linux-based distribution. Then for the various services, it's going to try and find where the logs are. So here's the logs for Nginx and the log for SSH, and finally the logs for the system. So now that it has a bit identified the environment, it's going to start suggest us collections. So what we call a collection is a parsers and one or more scenarios that are supposed to fit a technological stack. So here, for example, it was okay for SSH, I'm going to give you SSH parser and brute force detection, which is one of the most common attacks. When it comes, for example, to Nginx, it will be Nginx log support and classical HTTP detection scenarios. So more or less, for now, the setup is, or the configuration itself is finished. So we managed to identify the services, we managed to identify the logs, and we managed to pick collections that should be fitting our environment. And out of safety, we're deploying some whitelist just to avoid banning some private IP addresses. So once the setup is finished, as we can see, CrowdSec is immediately registering to the API. So the idea is that, as we said earlier, the API will be used to push signals to our central API so that in turn we can redistribute and share the information amongst all the participants of who is attacking what and who you should protect yourself from. The main way for the administrator to interact with CrowdSec will be through CSLI. So CSLI, for example, allow you to interact with bands. As we can see, we have something, but more importantly, we can see that the API already fed us with some IPs that are susceptible of attacking the technologies that we said that we're exposing and we want to protect. What we can do is that here I'm going to keep an eye at the log. And what I'm going to do is that I'm going to start Nikto. So Nikto, for those that are unaware, is a quite old-fashioned web application vulnerability scanner, but it has the advantage of being quite representative in terms of behavior. So I'm starting Nikto, and here, okay, I can stop. And we can see here my IP. So this is my personal IP has been triggered because it has triggered various scenarios. So one for trying to access a lot of non-existing pages, one for trying to access to a lot of non-static pages, and one to try to access sensitive files. So if I know, I look back in my ban list, I can see here that my IP has been banned. However, as an attacker, I still have access to my target because we only deploy CrowdSec, which is the detection part. So now I'm going to jump into the hub. And into the hub, as we said earlier, we want with the blockers to allow people to decorrelate detection and blocking. So I'm going to take a blocker for Nginx. Okay, so the blocker for Nginx is something that is going to allow me to block IPs that I've identified and have decided to block at the Nginx level. So I go back on my machine. I don't know this. So behind the scenes, there is no magic. The Nginx blocker is simply leveraging the power of UAS that is embedded into Nginx to be able to add this feature. So I'm going to restart Nginx. And now, because my IP here has been banned, if I try to access my website, now I'm blocked at the Nginx level. I get 403. So idea being that if instead of using like an Nginx plugin, you would use something that is more at the applicative layer, like Harper, you can have various kind of remediation. So this is for the blocker part. However, the thing that, for example, on my machine, I have configured my firewall to log the connections that are being established or refused. In terms of security, this is a very interesting information. So here again, we can go and use the hub in order to find the collections and the configurations that are relevant. So here I can look, for example, for the IP tables collection. So the IP tables collection will be a parser, so YAML file to allow us to parse the logs generated by IP tables, plus a scenario which will allow us to detect port scan. So I simply have here to copy this command and paste it here. It's going to download the new collection. So as we see, if we look into the deploy parser and scenarios, we can see that now I have a parser to be able to parse the logs of IP tables, and I have a scenario that allows me to detect port scan. So I'm going to reload. I'm going to reload CrowdSec. We are going to keep again I at the log, and now what I should be able to do is that I'm going to here be able to start port scan with Nmap on my target machine. Okay, I can stop. And here we can see that now, because we just added this parsers and scenario to be able to detect port scan from the logs that are generated by IP tables, my IP has been flagged again. And if I try to access to the website, I'm blocked. So of course, if we decide like to remove the here, I will be able to access to my website again. So the idea is that CSLI, it's a main interaction point, but as well, we believe that visualization is something that is quite important. So using the fantastic Metabase software, which is a visualization interface for various databases such as SQLite, MySQL, etc., we can deploy. We are going to deploy a dashboard on the machine in order to be able to visualize the items that we just blocked. So it's going to take a few minutes because the machine is not quite powerful, but you will see. In the meanwhile, so when we did the initial setup, we can see that the software, the wizard prompts us with which kind of scenario, etc., we want to deploy. And this is how we are able to be sure that the out-of-the-box configuration on the machine is going to more or less really fit the setup of the user. For the configuration themselves, when we speak about the scenarios, etc., it's always a YAML file. For example, if we look at port scan, how we can detect port scan, we are going to say it's one single IP that is trying to connect to a high number of distinct target ports on my machine. And this is exactly the representation of the scenarios that we use earlier, just to show a bit behind the curtain. Okay, so the setup of the dashboard is finished. So now I will be able to access here. So it just deployed the Metabase dashboard, and we'll be able to access it here. So of course, we are not going to see much data because we just deployed the software and we already did a few items. But here already we can have a visualization of the information with geolocalization, etc., the timeline, the kind of events that were detected, and the kind of operators. And one thing that is I didn't mention, but is rather interesting, is that for now we only see the part when it comes to the live detection. However, CrowdSec is as well able to work on code logs, because we know one of the recurrent fear when you write scenarios or something that is supposed to block an attacker is a false positive. What we can do here is that we are going to launch CrowdSec, and I'm going to use some old logs. For example, I take my Nginx logs from last year, and by injecting like this, we are going to see that here it starts to parse the old logs, and we can see that the timestamps are really in the past. So that if we go back to our web interface, and the debugger are still with us, yes, thank you, we can see that the old logs are being ingested with the correct time, etc. So the idea is that when you are writing scenarios or you want to try some things, you will be able as well to run it on call logs to see whether or not it would have triggered false positive, or if you are doing, for example, some forensic analysis. So this is about the demo, just to show the simple setup, etc., that we can have on a machine, and how we try to provide improved security somehow out of the box. I don't know, Philippe, if you are back or still some internet issues. Okay, so anyway, I'm going to continue the presentations and while waiting for Philippe. So a bit of storytelling. I don't know how clear was the demo, but so the idea is that it's something that on one hand can be used as simple as a software like a fail2ban used to be, and that is very lightweight to deploy. So you can deploy directly on your machine to provide some security. But as we saw, the blocking and the detection are really two separate parts, so that it allows us in a rather, I'm going to use my pointer here. You can see myself correctly, I hope. So we can see in a more classical information system that some of the infrastructure are on-premise, something is in the cloud, etc. And very often you are going to process your logs at a different place where you are going to want to act. Here we have some stuff that is in the cloud with, for example, an IP that is trying to breach our WordPress server. Other legitimate users, and here on the very right, one more user that while it seems to have a rather legit behavior, its frequency is way too high to just be a normal human. So all those logs that can be analyzed with CrowdSec. So we don't have to centralize all the logs at the same place. The idea is that you can analyze the logs where they are, and they are still going to push to a database, plus send us information. When we say send us information, the idea is to send as little information as possible. We're only going to send the meta information, which is the source IP that triggers the attack and that you block, the name of the scenario, if it comes from the as we saw, and the timeline. So very little information. And at the same time, you store this information locally, so that at various level of your information system, for example, not at the Nginx level, but rather at the WordPress level with the WordPress plugin, we're going to be able to block the attacker. And here on a more like, let's say, a business application, rather than purely blocking the suspect IP, we are going to present him with a CAPTCHA in order to check whether it's a human or it's a robot. Okay. So this was the idea of re-splitting the detection and the enforcement of the decision. So when we say blockers at any level, the idea is that the blocker, they all stick to the same behavior. Whenever they see a new IP address that they don't know, they are going to look into a local database or query an API to know whether or not they should apply an action. And depending on the answer, they are going to apply said action or not. For example, we just demonstrated during the demo the Nginx module that is using BLA, so which is allow us to simply block the user at the HTTP level. But at the same time, and following the same principle, we developed, for example, a WordPress plugin. The WordPress plugin developed in PHP will only allow you not only to block the user, like giving him 4 or 3 in HTTP, but rather, like, for example, to present him with CAPTCHA or to reduce its privileges or limit its action. The concept is that, Philippe will be back maybe a bit later, but the idea is that this approach is rather simple at implementing. If you look into the hub, you will see that we implemented blockers, for example, for WordPress, for Nginx, or more like fail-to-bind Golang daemon that is going to interact with your NF tables or IP tables system, or even leverage your SaaS provider, for example, Cloudflare, to be able to block larger scale attacks, as we know are quite common in some web context. So the idea is that these blockers are rather simple to implement. You query a database or an API, and you decide on not to act, so that we can use them at various levels of the stack, either at the applicative level with something like a WordPress plugin, or at the infrastructure level with Nginx, where you can protect your developers without them even being aware, or even at the infrastructure level, blocking at the firewall level. And the fact that the blocker itself is something that is very stateless, it makes it a good candidate to fit into the cloud. If you want to use it either on a Kubernetes or an ingress controller, or to use a Lambda or something like this in order to be able to protect your cloud assets. So, and all this, so for us, the target of the project is really to be able to create and maintain this huge reputation database to be able to share with everybody. And in order to do so, we need to have as many users as possible. And that's why we go on a quite permissive, let's say, open source license, which shows the MIT license to allow many usage, including binary distribution and commercial usage. And we are really committed to creating a community and making the usage as easy as possible. Hence the hub that we saw earlier, that for us is intended as a place for people to be able to find configurations that fit their use case, so that the technical barrier is as low as possible, but as well for people to push contribution and propose a contribution to the others. So here we are speaking about non-elitist security. So the idea is that, as we saw during the setup for a system administrator is the technical barrier is intended to be very low. It's very assisted. We redetect the service for him so that we can only do next, continue, and you have already a significant improvement of your security. The fact that the blockers are actually library in various languages that can be embedded into your application or into your infrastructure stack make it a good companion as well for the developers, so that they can give an applicative response, as we already saw in some cases, where developers will be afraid to rely on infrastructure to simply ban IPs, especially if you are, for example, let's say in the e-commerce context or things like this. While for DevOps, because we come as well from operation background, I've been working in a hosting company for quite a while, we try to do something that is really compliant with modern paradigms of deployment, such as public cloud, containers, Kubernetes, and so on. So on one hand, you have a very easy and assisted setup, and on the other one, you have something that is stateless and easy to deploy in highly industrial infrastructures. So the software itself, so CrowdSec, it drags a bit closer, let's say, from a fail-to-ban than from a full-fledged chain, because the idea is that we are only going to stream the data and we are never going to do retention. It's not meant to be using like Elasticsearch as a backend or to be storing a lot of information. On this aspect, it drags more from fail-to-ban. It reads the logs, it applies some transformation, some heuristic, and then it forgets about it. So there's aggregation, so the acquisition of logs, it can be either classical log files, but it's intended as well to be something like your AWS ClueTrail or streams of information that comes from the cloud or other providers. The logs are then parsed and enriched. So for parsing, we rely on the classical grok pattern embedded into YAML file to allow easy parsing. And for enrichment, it can be things as simple as geolocalization data, as we saw, but it can as well be enrichment based on your own database or existing threat and information database. Once this information has been enriched, we can confront them against the scenario. So the previous YAML files that we saw that allow you to describe this is a brute force, this is aggressive call, this is a port scan, etc. And then resulting of this, we have what we call a signal that is then pushed locally to a local database, like for example, SQLite or MySQL, to be able later to be read by visualization interfaces and the blockers, and to be pushed to our cloud. And we hope that this approach will make it very easy to be quite portable in a lot of context. So we saw that, but this is an example of our commitment to make something that is quite easy to use. We really hope that we can make the installation as easy as possible and that the user will be able to, out of the box, have a significant security. However, we know that maintaining security software in time can be rather challenging as well. And that's why the hub is here and allows you, for example, to update your collection or to automatically update your collection so that people can add new detection and you can get them automatically without having to do extra steps. But it should as well allow you to keep up to date with your evolution of technologies and the evolution of the threats. So visualization, we saw it, but the idea is that for a lot of people, visualization of security is something rather important. Things are clear when they are seen, and for this, we are relying on the open source software Metabase to provide out-of-the-box dashboard, as we saw during the demo. So to a bit of takeaways to sum up a bit Cloudtech is that so it's written in Golang. The idea is both the community and the portability, because we intend as well to target Windows environment, because there are sometimes there's not too many open source and free possibilities in terms of defensive security. In something that has been intended for observability, everybody hates black box, especially when it comes in terms of defensive security. So there's like a very strong Prometheus instrumentation that is already present to allow sysadmin to understand really what is going on and what actions are the thing taken. For more classical humans, we have the Metabase dashboard that we saw, and for system administrator, at least that aims to be as friendly as possible. And then something that is lightweight and declarative, intended for very versatile deployments such as containers, etc. So last but not least, because so far we only spoke about the software and its local capabilities itself. The real idea behind the crowd-feeded aspect is that some of the threats are very hard to counter on your own. Even if you have a strong security team and a good infrastructure, for example, things such as credential stuffing are way easier to be fought when you have a crowd and many people can report the same sightings, because the attacks, they are extremely short span and very sporadic. Plus, we think that when you speak about a threat, it has two aspects. First of all, it has a time, because an IP that is tagged malveillant at one moment was legit a few hours or maybe days or even weeks ago, but it has been hacked and then now it's taking part into attacks until its legitimate owner will be informed that the machine is behaving weirdly, and it will do what is necessary to fix, and then the machine will become legit again. So whenever we tag with a consensus system an IP as being malveillant, it's only for a short time. We are running a bit short of time, so. Then the consensus. We know that the consensus, so the fact of centralizing all the signals from all the community and redistributing them to the players and the people that are using the software is going to be the main challenge, namely the risk of poisoning. So for this, we have what we call a system of trust factor, so that when you start and you deploy the software, your voice is not going to count in any way. Even if you report IPs, your sightings are not going to be listened to until your trust factor reaches a significant level. Trust factor is intended to be something that will be hard or expensive to fake. So it will be based on things like, for example, the persistence at which you report signal or the consistency of the signals that you report. Then, because we know that the project is very young, we did the first release around a month ago, we are relying on a honeypot network. We deploy honeypots so that they are intended to, first of all, help us at the beginning to compensate the small size of the network and the community, and to be able as well to fill the gaps in terms of the technologies. Like, for example, if tomorrow there's a huge Drupal Geddon vulnerability that comes out that as we saw like a few years ago, we can easily deploy 1-200 Drupal servers so that we can catch very early the early signal of exploitation and share them as quickly as possible with the community. Then we have canaries. The idea is that we don't want to be seen as people taking into hostage other people's reputation on the internet. So we intend to apply the same transparent approach to whitelist and blacklist with canary system that will allow us and people on the GitHub, for example, server to declare pieces of infrastructure on the internet. Or this range they Google to Google bots. They might seem be seen as aggressive crawlers, but they are very legit, etc. So never ban them. This will help us to both make people more responsible and somehow guarantee to the users that out of the box, even with poorly configured scenario, he's not going to ruin his SEO because he's banning the Google bots from his servers. And last but not least, so it's really like the predictive part. So the thing that right now we're mostly relying on our honeypot or a few chosen partners in order to trust that signal and to be able to construct the consensus. But the more the network grows, the more we can really rely on all the open source participants that are feeding us signal to be able to detect who's good, who's bad, and to give back the signal to all the participants. So false positive are being the main issue, and that's why we are strongly believing that the canary approach will be a good idea, because it will as well help us to detect, to prevent scenarios with false positive from blocking legitimate IPs, and it will as well help us to detect if some canaries turn malveolent, or even as a good way to rate the scenarios that are produced by the community, because scenarios that starts to ban, for example, Google bot or search engine bots, it means that the scenario is sensitive to false positive. And we intend to keep all this as open as possible on GitHub or such platform where people can contribute, challenge, etc. the canary list that we are going to provide. This is the end of the slides. Do you have any questions? I'm going to check in the Q&A.
Okay, well, thanks for the talk first. Sad that that Philippe had to display. So well, no question in the QA at the moment. I had an idea that came to mind. Yes, yesterday we had a speaker. It's Alexandre Dulaunois. He's one of the initiators of a project that is called MISP.
Yes.
You know about it? Yeah.
Yeah, definitely.
The malware information sharing platform. I was thinking that it could be a source of information for CrowdSec. So yes. Do you have this database as an input yet? Or?
Yes, definitely. So the thing that the project is still at the very early stage for now. We released like the open beta around a month ago. So we are taking steps, let's say, to ensure that things are going well and we start to have our first scale, big scale, let's say, deployments. But the idea, yes, is really to be able to leverage on the community as much as possible. MISP will be one example. As well, we can take inspiration from all the blacklist mechanisms that might exist for spam, with the difference that we are really convinced that the temporality of the information of who's good, who's bad is something that needs to be taken with care, especially with public cloud now and the reuse of public IP address. We really need to give this a small temporality. Yeah,
of course, the detecting or the injection of your, for example, your own IP addresses is important. Yeah. Well, I had another question, but it's not technical. I was just wondering what is if you could talk about your background or what compelled you to start this project.
Yeah, sure. So yes, sorry, I forgot to present myself. So I'm Thibaut Quéclin. I used to work in a company called NBS System. Originally, I come for a more offensive background, pen tester, etc. But for a few years, I've been really focused on building defensive system for hosting infrastructure. In the past, for example, I've written Naxi, which is a web application for Nginx. Or more recently, we published Snuffleupagus a few years ago, which is a hardening module for PHP. So let's say that I've been focusing on defensive system for quite a while now, and in our past experience, we already had the occasion to work on, let's say, some homemade SIEM approach. So parsing logs and trying to detect things automatically to give automatic answers, because we believe that in terms of defense, it's really become like a economic, the best way to fight with attackers on the economic aspect, and making it as painful as possible for him so that he switched to another target. So.
Yeah, an understandable approach. Yeah. Okay. Well, so I guess we're right on time.
Perfect. I will stick around on IRC if some people have questions, etc. I forgot to. I realized I forgot to link the GitHub beta, but I will put it in the presentation if people want to come, and we are happily looking for beta testers. So
yeah,
there's someone asking a question. What's your plan to prevent botnet submitted signal to either let an attack pass? Ah, yes, very good question. So someone is asking, so it's more or less about poisoning people, like using botnets that will feed us some wrong signal. So the plan is we are using a system of trust factor. If you deploy right now the software and you feed us some messages, your messages are going to be somehow ignored because your trust factor is considered to be very low. What we are going to do is that we are going to give a trust factor to every users based on various stuff, such as, for example, the persistence. So if you want to have a chance to be able to even contribute to a decision or a consensus, you will have to, let's say, have the software running for at least 1 month with a very frequent and recurrent submission of information. Then there is as well the consistency of the information. For example, your trust factor is only going to increase when you submit a report for an IP that will later have a consensus from stronger IPs. Like you report, oh, 1234 is doing SSH brute force, and then 20 minutes later, we have several other people reporting it, and we are saying, okay, there's a consensus that 1234 is really performing SSH brute force. Okay, so it means that this peer, he's really listening to some real internet traffic and he's feeding us some right information. So to answer the question, the idea is to really give a trust factor to every participant so that we can decide whether or not to trust some sightings, and we are using a fact that more than one IP, etc., need to be reporting the same attack for us to make it part of the consensus. So if there's no other question, anyway, we'll be available on IRC and such, and I will include the GitHub links, etc., in the presentation. And in the meanwhile, thank you everybody for your time and your attention.
Thanks, and yeah, don't forget to send us your slides with all the info. Okay, so this will conclude the talks for today. So just a quick reminder, you can find on the website, on the schedule page, you can find the link to the slides and to the videos, at least for yesterday's talks, and we will put the links to the videos this evening when the videos have been processed. And then, so I will leave the mic to Clément so that he can introduce his concert that will be at 5:15. So, Clément.
Hi. So I'm talking in English for the presentation, but the concert will be in French because I only write songs in French, and I hope that a lot of you will come. It will not be broadcasted on Zoom. It will be directly broadcasted on YouTube, and I think you have all the information on the website, and maybe some first look on what you want to hear. l'argent ne fait pas le bonheur. L'homme est de bien meilleure humeur. Je ne laisse rien au hasard, pas le moindre petit pourboire. Alors je suis de la race des profiteurs. Une mercantile fière successeur qui a fait de moi un homme d'action, négocié à la sueur de mes fonds. Et voilà la suite tout à l'heure à 17h15 exactement. Merci.
Merci Clément.
Merci. For those who are following us on YouTube, it will be another YouTube link. So pay attention, check the website, and switch to the other stream. Thank you.
So see you for the concert, and see you tomorrow for the next talks and the final day of this Pass the Salt edition. Thank you, and see you tomorrow.